Academy. In this video, we'll be solving the question 7 of the 2017 Core Math WASSCE questions. I read the question. A bag of food aid is released from an aeroplane which is 1,000 meters above a military camp. The height h meters of the bag above the camp at the same time t seconds is given by the relation h is equal to, this should be 1,000. So h should be equal to 1,000 minus 5t squared. A. Copy and complete the following table for the relation h is equal to 1,000 minus 5t squared. B. Using a scale of 2 centimeters to 2 seconds on the t-axis and 2 centimeters to 1,000 meters on the h-axis. Draw a graph of the relation h is equal to 1,000 minus 5t squared for t between 0 and 15. C. Use the graph to find, correct to 1 decimal place, the I. Time the bag takes to the ground, II. Time the bag takes to drop through the first 640 meters, III. Height of the bag above the cap after falling for 7.5 seconds. So let's move on to the solution. So question 7a. We are asked to complete the table. So time in seconds, height in meters, and time is between 0 and 15. All right, so we have the relation h is equal to 1,000. So h is equal to 1,000 minus 5t squared. All right. So we'll be completing the table using this relation. So when t is equal to 0, h is equal to 1,000 minus 5 into bracket 0 squared, which is equal to 1,000. So you do the same for all the values of t, and we should have 995 for t is equal to 1, 955 for t is equal to 3, 755 for t is equal to 7, 755, 595 for t is equal to 9, 595, 155 for t is equal to 13, and 125 for t is equal to 15. All right. So that will be for the 7a. Now B. Using a scale of 2 centimeters to 2 seconds on the t-axis and 2 centimeters to 1,000 meters on the h-axis. So we know our t is the x-axis, and then our h will be our y-axis. So we will have this for our y-axis and this for our x-axis. Our x-axis will be our t, will be the same as our t-axis. And our y-axis will be the same as our h-axis. All right. So we are being asked to take 2 centimeters to 2 seconds on the t-axis. 16. So time is in seconds. And height is in meters. And we are being asked to take 2 centimeters to 1,000 meters on the h-axis. This should be 200 meters. So 2 centimeters to 100 meters on the h-axis. So, and we have 100. Now let's plot our points. When t is 0, h is 1,000. So, be here. When t is 1, h is 995. So at 1, we'll be here. When t is 3, h is 955. So at time 3, it will be here. When t is 5, our h is 875. So 5 will be here. When t is 7, our h is 755. So 700 will be here, somewhere here. So for 9, our h should be 595. So for 9, should be here. Then when t is 11, our h will be 395. So 11 will be somewhere here. And for 13 will be 155. So 13, 155 should be here. And for 15, we'll have 125. So 15, 125 should be here. So remember, this is not drawn to scale. You have this. All right. So that'll be for question 7b. Now moving on to question 7c. It says use the graph to find correct to one decimal place the I time the bag takes to the ground. So question 7 CI. So when the bag gets to the ground, h will be 0. So we are finding t at h equals 0. And this will be our t. This will be our t at h equals 0, which is almost 15 seconds. That when h is equal to 0, t should be between 14 and 15. Now, it says the time the bag takes to drop through the first 640 meters. So, h new will be 1000 minus 640. And when you do the subtraction, you should get 450 meters. So at h is equal to 450 meters, what will be our time? So 450 should be somewhere here. So at 450 meters, our t should be 10.4 seconds. So t should be equal to 10.4 seconds. And then I. So CII. Height of the bag above the cap after falling for 7.5 seconds. So 7.5 seconds should be somewhere here. So that will be around 650 meters. So when t is equal to 7.5 seconds, h will be equal to 650 meters. So that brings us to the end of the question 7. If you enjoyed this video, please don't forget to like and subscribe. Thank you.